This problem is a wonderful example of why geometry is often more about seeing relationships than doing calculations. At first glance, we have a square, a slanted line passing through it, and 3 lengths marked along that line. The left outside segment has length 5, the segment inside the square has length 15, and the right outside segment has length 10. Our goal is to find the area of the square. Now, many people immediately start thinking about the Pythagorean Theorem, but if we try that right away, we run into a problem. We do not yet know the side length of the square. We do not know any useful angles, and we do not have enough information to build a right triangle with known sides. So instead of chasing measurements, let's look for patterns. And while you're following along, if you enjoy these geometry puzzles and the way we break them down step by step, make sure to like the video and subscribe to the channel because we solve problems exactly like this together every day. Now let's continue. Let the side length of the square be t. Also, let's call the horizontal distance on the left side m and the horizontal distance on the right side n. Notice that the slanted line creates several right triangles. The important observation is that these triangles are similar. Let's look at the small triangle on the left and compare it with the large triangle formed by the entire figure. Both triangles contain a right angle. In addition, they share the same acute angle along the slanted line. Whenever 2 angles of one triangle match 2 angles of another triangle, the triangles are similar by the angle-angle similarity rule. And once triangles are similar, corresponding sides are proportional. That is the key idea that unlocks everything. Now let's define the entire horizontal distance from the far left point to the far right point. That total distance is m plus t plus n. To make our work cleaner, let's call this quantity k. So k equals m plus t plus n. Since the small left triangle is similar to the large triangle, the ratio of their corresponding horizontal sides must equal the ratio of their corresponding hypotenuses. The horizontal side of the small triangle is m, and the horizontal side of the large triangle is k. The hypotenuse of the small triangle is 5, and the hypotenuse of the large triangle is the entire slanted segment. Let's calculate that total slanted length. We simply add the 3 given pieces. 5 plus 15 plus 10 equals 30. Therefore, the similarity ratio gives us m divided by k equals 5 divided by 30. 5 divided by 30 simplifies to 1 divided by 6. Therefore, m divided by k equals 1 divided by 6. Multiplying both sides by k gives m equals k divided by 6. Keep that result because we will use it shortly. Now let's examine the triangle on the right side. Once again, this triangle is similar to the large triangle. The reason is exactly the same. Both contain a right angle and they share an acute angle along the slanted line. Therefore, corresponding sides are proportional. The horizontal side of the right triangle is n, while the corresponding horizontal side of the large triangle is k. The hypotenuse of the right triangle is 10, and the hypotenuse of the large triangle is 30. So, we can write n divided by k equals 10 divided by 30. 10 divided by 30 simplifies to 1 divided by 3. Therefore, n divided by k equals 1 divided by 3. Multiplying both sides by k gives n equals k divided by 3. Excellent. Now we know m in terms of k and we know n in terms of k. The next step is to express the side length of the square in terms of k as well. Remember our definition, k equals m plus t plus n. Rearranging this equation gives t equals k minus m minus n. Now let's substitute the values we found. T equals k minus k divided by 6 minus k divided by 3. Let's combine those fractions carefully. The common denominator is 6. K divided by 3 is the same as 2k divided by 6. Therefore, t equals k minus k divided by 6 minus 2, k divided by 6. Combining the fractions gives t equals k minus 3k divided by 6. Since 3k divided by 6 is equal to k divided by 2, we get t equals k minus k divided by 2. And k minus k divided by 2 equals k divided by 2. So we have discovered something very important. T equals k divided by 2. In other words, the entire horizontal distance k is exactly twice the side length of the square. This is the breakthrough moment of the problem. Up to this point, we have not used the Pythagorean theorem at all. We only used similar triangles and proportional reasoning. But now, we have enough information to bring in the Pythagorean theorem. Let's look at the large right triangle. Its horizontal leg is k. Since k equals 2t, we can replace k with 2t. Its vertical leg is the side length of the square, which is t. And its hypotenuse is the total slanted length, which we already found to be 30. Now, recall the Pythagorean theorem. For a right triangle, the square of the hypotenuse equals the sum of the squares of the two legs. Applying that theorem gives the quantity 2, t all squared plus t squared equals 30 squared. Let's simplify each term carefully. The quantity 2t all squared becomes 4t squared. T squared remains t squared. 30 squared equals 900. Therefore, we have 4t squared plus t squared equals 900. Combining like terms gives 5t squared equals 900. To isolate t squared, divide both sides by 5. This gives t squared equals 180. Now remember what the problem actually asked us to find. It did not ask for the side length. It asked for the area of the square. The area of a square is side multiplied by side, which is simply t squared. And we have already found t squared. T squared equals 180. Therefore, the area of the square is 180 square units.